Let's go to page 251 and start with number 1, A. So for 1A, you have square root of 64. Now to simplify the square root, there are several ways you can do this. One way is by making this into 8 squared. And so that square and square cancel out, so this will equal to 8. So easy number, you can do that. Or you can, now if the number gets more complicated, you want to do is break it into prime factorization. Okay, so divide by 2, you get 32. So break it down into prime numbers. And so keep doing that. Now, a lot of times people will kind of forget this number, so I'm going to keep going until I get 1 over here. So I get all the numbers on the side. Now, what the square root means, so when you don't see a number over there, that means it's a 2. So that means it takes 2, so this number is called radicand. So when you break it down, so the 2 radicands where it becomes an integer, and this 2 becomes another 2, and this becomes 2. Okay, and so this will give you 8. So either method, you can get the answer. Okay, now let's go to 1b. You got square root of negative 64. So for this one, notice you cannot get something times something equal to negative 64 when you deal with real number. Because if you have negative 8 times negative 8 give you 64. Positive 8 times positive 8 give you 64. So there's no way you're going to get the negative 64 from the real number. So in this case, this is not a real number. Okay. Now 1C, you got negative 64. Now negative on outside is fine. So you do one of this method. Okay, so you know that this part is going to, so keep the negative, and this one from the 1A is going to be 8. So your answer would be negative 8. Okay. And 1D, you have cube root of negative 64. Now this is different from this because now you can get negative with the cube. Because again, if you do it this method, you can have a negative 4 to the 3 power. Okay? So negative times negative times negative give you negative, right? So when the index is odd, then it's okay. The only time you cannot have is when index is even and you got negative on the inside. Okay, so now with the odd number, you can just cancel out. So this and this will cancel out. Technically, you kind of have to break it down into the negative 4, negative 4, negative 4. And so this way, able to cancel out. So you're going to get negative 4. Okay. And when you're doing the prime factorization, okay, just like before, and you can ignore the negative, okay, because negative will be just on the outside. So when you break it down, you get 2, 32, 2, 16, 2, 8, 2, 4, 2, 2. Again, that's going to get all the way down to 1, so that way you got all the number on the side, so that way you don't forget this number over here. Now index is 3. See over here, the index is 2, so you get 2 radicand becomes an integer. But now, index is 3 means you need to get 3 radicands become an integer. And this 3 becomes an integer. Okay? So this will equal to 4. And remember there's a negative, right? So you have to take care of the negative. Okay? So this only take care of the numbers. This does not take care of the negative. So you have to kind of watch for the negative. Okay, let's go to number 3. Uh, 3A. Square of 0.01. Okay, again, there are several ways you can do this. One way is you make into fraction. So this is equal to square of 1 over 100. And then you take the square root of the top and bottom individually. So square root of 1 is 1. Square root of 100 is 10. And so that's it. Okay. Now another way to do it is if you have all the 0 in the front or if you have all the 0 in the back, this is another way you can do this. Okay. So since the index is 2, okay, so that means 2 digits inside will make 1 digit on the outside. and you start with the decimal and you chop off, every two numbers, and you take the square root. So square root of 0 is 0, and decimal is decimal, and here's your 1, right? So square root of 1 will give you 1, okay, and that's it. Okay, either way. But again, you got to be careful with this technique. Okay, this only works if you have all the zeros in the front or all the zeros in the back. Okay, let's go to 3b. Okay, you got square root of negative 0.01. Again, when you have the negative inside the square root, this is going to be not real. Okay, let's go to 3c. You have negative square root of 0.0036. So again, you can do it by this technique, convert into fraction. And so this would be 36 over 10000, right? And so there'll be negative, okay, square root of 36 is 6. Square root of 10,000, okay, is going to be equal to 100. Okay, and if you convert into decimal, you're going to get negative 0.06. Okay, either one is acceptable. Another way to do this method is you got 0.0036, right? Again, you can. So since the index is 2 over here, so every 2 digits in the right can become 1 digit in the real number. So chop it up. Again, you have to start with the decimal point. Chop up into 2 digits. So the negative will give you negative. 0, square root of 0 will give you 0. And you got decimal here. Square root of 0 give you 0. Square root of 36 give you 6. And again, you get the same answer. But again, you have to be careful with this, okay? You only can do it with all the zeros in the front or all the zeros in the back, okay? You cannot have the digits between the zeros, okay? Okay, let's go to 3D. Okay, so 3D. You have square root of negative 0.0036 squared. Now, this is what allows you to do. They cancel out the square and the square root, okay? And then you end up with negative 0.036. Again, that's incorrect because technically you have to square first. So negative square will give you positive. And when you take the square root of positive, it will give you positive, okay? So you can negative, you have to square that and take the square, give you positive. So take care of the sign. Now when you take care of the number, now it's okay to, so you take care of the sign first. Now the number, you square and you take the square root, so you stay the same. So it becomes 0.0036. Okay. So again, be careful. Don't just cancel it out and you end up with negative as your answer. Okay, that would be incorrect. Okay, because again, you have the technique, you have to use a negative, you have to square that, it becomes positive. And you take the square root of positive, it gives you a positive. Okay, let's go to 5. Okay, 5a, you have square root of 3 squared plus 4 squared. To simplify this, again, these are terms, so you cannot just take out. You cannot just take it out. Okay, so this will equal to square root of 9 plus 16 equal to square root of 25 and equal to 5. Okay, so again, you cannot just go and take it out and take it out. Okay. Okay. Now you go to B. You have square root of 3 plus 4 squared. Now this one, there's no negative, so we're safe. So we can just cancel out the square and the square root. So the square and square root will cancel out. So you end up with 3 plus 4, and so equal to 7. Okay. So notice the difference between the two. Okay, let's go to 5c. 5c, you have square root of 3 minus 4 squared. So again, you have to be very careful, right? You don't just cancel that out and end up with 3 minus 4, end up with a negative 1. That would be incorrect, okay? So again, with a negative, you have to follow through the order of operation. So this one, you're going to get negative 1 squared. Okay, and you square that, you're going to get square root of 1, right? Negative 1 squared is 1, and this will equal to 1. Okay, so don't just cancel out and make into 3 minus 4 and equal to negative 1. That would be incorrect. So again, a lot of little things to watch out for. Okay, so 5D, you have square root of 3 squared minus 4 squared. So again, this one you can do not take it out. Okay, you cannot just okay, this become the square and square cancel out. Okay, you cannot do that because these are terms. Okay, so you have to work throughout each one. So 3 squared is 9, and 4 squared is 16. So this is equal to square of negative 7, and you got negative inside the square root. So this is not real. Okay, so again, you got to watch what you're doing. Okay, let's go to number 7. So 7a, you have square root of 10 to the 4. So again, index means there's a 2. So this is actually becomes 10 to the 4 divided by 2. Okay, so there's a 2, invisible 2 right over here. That's what the square root means. Okay, and so the exponent goes on the top and the index goes on the bottom because they're reciprocal of each other. And so this is equal to 10 to the 2, so this is equal to 100. Okay. So you don't have to show all these steps, but I'm showing all the steps so you can follow what I'm doing. Okay, so let's go to 7b. So you have the fifth root of 10 to the 10. So again, this is going to be equal to 10 to the 10 divided by 5. Okay, so 10 divided by 5, so equal to 10 to the 2, so this is equal to 100. Okay, let's go to 7c. You have cube root of 8 times 10 to the 3. Okay. So now these are two. You can think of that as a 2 factors. So you can do each part individually. So again, you can kind of chop it up. Okay. So cube root of 8, okay, is going to be equal to 2, and cube root of 10 to the 3. The 3 and the cube root will cancel out, so it becomes 10, and so this will equal to 20. Okay, let's go to 7d. So you have the fourth root of 1.6 times 10 to the 5. Now this method is not going to work because this is a 4 and this is a 5. Okay, so what you need to do in this case is that you want to make this exponent same as the index or multiple of the index. So you want to make this into the fourth root of 16 times 10 to the 4. Okay? So 1.6 times 10 to the 5. So make one of the 10 into here. Okay? So that you end up with a 4. Okay? So now you can go and use the technique over here. Right? Okay, you can chop it up. So the fourth root of 16 will give you 2. And 10 to the 4, the fourth root, the 4 will cancel out. So this becomes 10. So this is equal to that. And so this will equal to 20. Okay, let's go to number 9. Okay, so 9a, you have square root of x squared. Okay, so in this case, don't just cancel and write down the x. Okay. Because what happens if x is negative, okay, if the x is negative and when you square it becomes positive and you take the square it becomes positive. But if you start with negative, now you end with a positive, right? So in this case, when you have the square, you need to, this will equal to absolute value of x. Okay, so again, the answer will always positive because if the x is negative, when you square, you're going to get positive, and you positive when you take a square, you're going to get positive, not negative. Okay. So again, that's why the answer will always positive. So you have to put absolute value in case if you start out as a negative for the x. And there would be this would be like this kind of situation over here, like this one over here. See, if you start out negative, right? If you start with negative, you square, you're going to get positive, and the answer is going to be opposite. Okay. So that's why you need to put absolute value when you have the square. Don't just cancel it out, okay? Okay, then you got, let's go to 9b. You got x to the 4. So again, this is going to be equal to x to the 4 over 2. And so equal to x squared. Now this one you don't need an absolute value because you have a square over here. So so no matter what x is, if it's positive or negative, when you square it's always positive. Okay, so you don't need an absolute value. This one you do, because this one you don't have a single power, right? This one you have a square, so it will always positive already. Okay, so you don't need the absolute value. And 9c, you have square root of x to the 6. So this is equal to x to the 6 over 2, so equal to x to the 3. And again, because this is an R power, so you need to get absolute value, okay? Because if x is negative, okay, and if you put over here, it's going to be negative, right? So you have to put absolute value. Okay, let's go to 9d. You have square root of negative x to the 6th power. Okay, so again, in this case, you can go ahead and this is going to be same as this, and it's going to be, and because it's the 6th power, it's even, okay? So when you have negative to the 6th power, it's always going to be positive. You take the square, it's going to always positive. And so again, you need to have absolute value. Okay. Okay, let's go to number 11. It says find the principal square root of 4 million. Okay, so you're looking for square root of 4 million. Okay, so you have several ways you can do this. One way is by making to scientific notation. It would be 4 times 10 to the 6th power. And then you can do that. So this will become, I can chop it off. So square root of 4 is equal to 2. And square root of 10 to the 6 will be 10 to the 3. And so this will equal to 2,000. Okay. Or, when you do it this way, again, notice everything is all 0 in the back. So here is your decimal point. Now again, index is 2, means you have to chop into 2 digits at a time. Because again, when you have square root, means 2 digits inside will equal to 1 digit outside. So chop off, starting from the decimal, go this way or this way. So this way, this way, this way. Okay, so square root of 0 is 0, square root of 0 is 0, square root of 0 is 0, square root of 4 is 2. Again, same answer, right? Okay, but again, you have to be careful with this method. You only can do it with all the zeros on the back or all the zeros in the front. Okay, if you have the other digits right in the middle, then this method cannot work. Okay, because this method is kind of based on this technique over here. Okay, let's go to 13. Okay, you're looking for the, so again, you have to translate. So square root of the cube root of n is 5. Okay, so now you solve for n. So first you have to, it's almost like an onion. You have to peel off from the outside, right? So first you have to get rid of this layer. So to do that, you need to square both sides. Okay, so go and square both sides. So the square and square root cancel out. So you got cube root of n equal to 25. And after that, to get rid of the cube root, you need to cube both sides. Okay, and so the cube root and cube cancel, cube and cube root cancel out. So n equal to, now you're going to work out this number, and so this will end up with 15625. Okay. Okay, let's go to 15. You got 3x squared equal to 75, and you're solving. So first you divide by 3. So you got x squared equal to 25. And then you take the square root on both sides. So that's going to take the square root on both sides. And when you take the square root of a variable, you need to put plus or minus on the other side. So x will equal to plus or minus 5. Okay, let's go to 17. You have 2x squared plus 18 equal to 0. So first let's move the numbers to the other side. So you got 2x squared equal to negative 18. Divide by 2. Again, you want to get perfect square, so you can take the square root. So you got x squared equal to negative 9. And you take the square root. and put a plus or minus. And right away you can see that when you have the negative inside the square root, it's not real. Okay. Okay, let's go to number 19. We got 3n squared, 3n cubed minus 3 equal to 0. Okay, so equal to 3. Equal to 3. So first, let's go ahead and plus 3 on both sides. So you got 3n cubed equal to 6. So this is a 3. Okay. And then after that, you want to get rid of that 3. So divide by 3. So n cubed equal to 2. Then after that, to solve that, to get rid of the cube, you need to take the cube root. Okay, so that's going to take the cube root. Now, when you're taking the cube root, if the index is odd, you don't have to put plus or minus. If it's even, you have to put plus or minus. So the cube and cube root cancel out, so n equal to cube root of 2. And that's it. Okay, let's go to 21. You have a squared over 3 equal to 300. So that's going to give rid of a fraction, so multiply by 3. So a squared equal to 900. And after that, take the square root. And again, when you do the square, you have to have a plus or minus. So a equal to, again, to simplify this, you start off here, chop it off into every 2 digits, right? So square root of 9 is 3, and square root of 0 is 0. And therefore, your answer will be plus or minus 30. And that's it for number 21.